Hi guys, Miss Co here with your lesson on 4B Part 1. In 4B Part 1, we start talking about the GCF, and GCF stands for Greatest Common Factor. And when we're using that term greatest, when we're talking about the GCF, we're talking about the highest number, Common means that we're comparing two different terms, and we're looking at factors that are the same between the two terms. The word factor, as we remember, is it means a whole number and that divides another number evenly. Okay, so that means when we divide a number, we're not going to get a decimal when we divide by our factors. Okay, no decimals. Let's look at our first example. Okay, our first example. And the first example that we're going to look at is the number 24. And we're going to compare it to the factors that we have for 18, okay? And keep in mind that we're going to do this first example we're going to do it manually. And then I'm going to teach you guys how to do it with a calculator. So let's look at the factors for the number 24. When we're looking for factors, we're going to start dividing by 1, our lowest number. And when we divide 24 by 1, the answer is 24. So 1 times 24 is 24. These are factors because they divide into the 24 evenly, right? Then we're going to divide by 2, and 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. And you can see that all of these are whole numbers. If we keep dividing, we aren't going to get any new factors. They'll be decimals, okay? It doesn't matter which order these numbers are in. When they're grouped like this, when we multiply 4 times 6, it equals 24. We call that a factor pair. All these are factors of 24. These are groups of factor pairs. Okay, let's take a look at 18, the next number. And guys, on this problem, I want you guys to always pay attention to what you're being asked to do. On this first example, we're asked to find the GCF. Find the GCF. Sometimes you're going to see it lowercase like that. Sometimes you're going to see it uppercase. But because we're going to start talking about finding the GCF on your calculator, and on the calculator it's lowercase, I'm going to start writing it like this sometimes, okay? All right, now the factors for 18, we always can divide evenly by 1, of course, but we also have 2 and 9 and 3 and 6. So those are all of the factors for the number 18. There are no other whole numbers that we can divide 18 by and get a whole number answer, okay? So when we're finding the GCF for two different terms or two different numbers, we're comparing these lists. We're going to compare those lists. And we're looking for all the numbers that are the same. So we're looking for the factors that are the same. So let's go ahead and do that. So when we're finding the GCF, we're comparing the factors between two different terms. And we can see that they both have a factor of 1, both have a factor of 2, they both have a factor of 3, and they both have a factor of 6. These are all the factors they share in common. But to find the GCF, we need the biggest one. and that's 6. So when we find the GCF between 24 and 18, the answer is 6. That's our GCF. All right? All right, guys, let's go ahead and do our next example. So for our next example, we can see that we're asked to find the GCF again. This time it's between a different type of term. We've got the first one, which is 3x cubed, and then another term, 9x squared, and then we also have 6x to the 4th power. These are our 3 terms. How do we find factors when not only do we have a number, but now we also have this component where we have a variable and an exponent? When we find the factors of each individual term, we're going to always look at the factors for the number part. So the first thing we'll do is we'll find factors for our number part, and then we're going to find the factors for the variable part. The variable with exponent part, and I'm abbreviating here. Okay, these are the 2 different parts that we need to factor. So let's go ahead and get started. Our only factors for 3 are 1 and 3, and x cubed, or to the 3rd power, means x times x times x. So these 3 x's multiplied together, that means x to the 3rd. All right, let's look at 9x squared. The factors for 9 are 1 and 9 and 3 and 3. So the number part first. Now we'll do our letter part, or our variable part. X squared means x times x. And now let's look at this final term. Our factors are 1 and 6, and then of course 2 and 3. On this term, we've got x times x times x times x, and that's what our x to the 4th power means. So when we find the GCF for terms that have both a number part and a variable part, we are going to identify the factor all 3 have in common, the biggest one they have in common, and then we'll also identify variable parts that they have in common the most. So since this middle term has x times x and all the terms have that, our GCF is 3x squared. All of our terms have 3x squared in common, and that's the biggest term that they have in common. And that is our GCF when we're looking at terms that have both a number part and a variable part. All right, let's go ahead and move down the page. On page 4 of your notes for 4B1, the first factor example is number 1, and it's asking to factor out the GCF. Factor out the GCF. We looked in the prior examples on how to find the GCF. And when we factor out the GCF, we're going to need the GCF. So we'll first identify the GCF. And then we're going to divide it out. Divide the GCF out of every term. Okay? Let's see how we do this. So our first example is 8x squared plus 12x. Let's go ahead and look at the factors for each term. Remember, this sign to the left of the 12x goes with that term, okay? So the number part of this term, the factors would be 1 and 8, and then 2 and 4. The variable part would look like this, x times x. For this second term, our factors are 1 and 12, 2 and 6, and 3 and 4. For the number part, we only have one x on that second term. So the GCF, which is our first step, would be, we'd only have one x that we could take and a 4. So our GCF is 4x. Now to do that second part, to divide out the GCF, we want to put that original problem into a box. We'll put it into a box. And right in front of that box, right here, we're going to put that GCF that we just found. So this is how it would look. So we'd put that 8 x squared. Now again, this is our original problem here. 8x squared, and then that plus 12x inside a 2 by 2 box. On the outside and the front, we're going to put that GCF that we just found. So we know that between these two terms, here's our GCF. And now we're going to divide it out of our terms here. So when we divide out a 4x from this first term, we'll have a 2 left and an x. And we'll put that up top here. And you'll notice if we multiplied with that number, 2 times 4 is 8. X times x is x squared. So you can look at those factors that we've left behind like we did on that last term. Or what we can do instead of looking at what we've left behind is we can go up top here and we can ask ourselves, what do we need to multiply 4x by to get to 12x? And we're always going to bring this sign up. And what we would need is a 3. 3 times 4 is 12. We don't need any more x's. We already have an x on this term. So 3 times 4x is 12x. When we divide 4x out of our original term expression, we have 2x plus 3. So for our answer, when we answer these problems, we'll put our GCF out front for our answer. Again, remember that's this GCF right there, okay? The GCF goes first, then we'll put a set of parentheses, and inside we'll put those terms from the top, right? 2x plus 3. And that's our answer, guys. Here's the thing. Remember that factoring is like dividing. It's the opposite of multiplying. So our answers look like a multiplication problem because we're doing a multiply problem backward, right? So factoring is a lot like dividing. Let's look at number 2. Number 2. So the problem is 10x cubed minus 15x squared. And our GCF, we can start kind of getting a sense of our GCF just by looking at it. Our number, the factors for the number part on our first term, 1 and 10, 2 and 5. And for the letter part, we've got x cubed. That means we need an x times x times x. For that second term, we want to notice we have that negative. We always want to be real careful for our signs. And we'll look more about what to do with our negatives later. But right now, let's focus on what the number part of our factors are for 15. So the only number factors for 15, 1 and 15, 3 and 5. Then, of course, for our variable, x squared is the same as x and x. When we're picking our factors, we're comparing the list for the number part, comparing the variable part. So our greatest common factor for our number part is 5. And since the term with the fewer x's has x squared, and we have that for our, the term that has more x's, our GCF is 5x squared. You always want to look at that short list, right? We can't take any more than the 2 that we have here. And then, of course, we're going to put that original expression into a 2 by 2 box. It'll look like this. Because now what we want to do is factor out the GCF or divide out the GCF. Our first original term goes in that first box. And here's the second one. Okay. Out front here, that's where we're going to put that GCF that we found. So that'll go out front here. So our greatest common factor, 5x squared. And up top here, we want to divide 5x squared out of 10x cubed. I think the easiest way to do it is to ask, what do we need to multiply 5x squared by to get back to 10x cubed? So we would need to multiply 5 times 2, and we don't have enough x's, so we need another x to get to x cubed. But if we look back over here at our original factors, when we divided out the 5, we have a 2 left. When we divided out this x squared, we have an x left, and that's what we would expect here, and indeed what we find. All right, for this second spot, what do we need to multiply 5x squared by to get back to negative 15x squared? So we have enough x's. We want to bring that negative up, okay? Here's that negative, and 5 times 3 is 15, so we'll have that 3. All right, for our answer, we want to bring these terms down. They go in the parentheses, and of course our GCF term goes here in front. So right out in front, our GCF, right? And inside the terms left when we factor out or divide out the GCF, okay? Here's that answer for example number 2, page number 4 of your 4B1 notes, okay? That is the end of part 1 of your 4B1 video. Go ahead and go back to your video links for the next part of your 4B1 lesson and more examples worked from 4B1. All right, guys, thanks for watching. Cue up that next video. Thanks.